When I say the words space exploration, probably the first thing that you think about is an image of a human on the moon. This was Apollo 11, 1969. But today, I'm not here to talk about this mission. I want to tell you things that happened before this moment, on July 20th. My name is Ahmad Salah. I'm an astronomy and education for astronomy and space sciences, also a content creator. And today we're going to take a look at things that happened, or changes that happened on an elementary level that paved the way for the space exploration industry. This is an incredible picture of Neil Armstrong on the moon. Today, we have pictures that look like this. This is the International Space Station. It's a space lab that goes around the Earth at 28,000 kilometers an hour. That's almost 7.7 kilometers 1 second. And people live in these space stations. But how did we get here? We need to step back a little bit, go back in time, run the time machine back to the time when the space race was happening between the US and the Soviet Union. I'm going to take you back in our time machine to 1958. At this point of time, there was an announcement that by the end of the next decade, we'll be having a human on the moon. Now, to get to that point, we need to start developing something that's big. So the Apollo missions started at that time. This is Saturn V, one of the best rockets, I would say, at that time, the most powerful one at that time, too, to get human beings out of the space station, out of the space, out of the orbit of the environment, and the outer space orbit to get to the moon. But this one had problems in the beginning. This is one rocket with 3 stages. The bottom stage has engines in it, obviously. And before this Apollo, before this Saturn rocket, there were smaller rockets. They needed less amount of fuel, and they burned quickly, and the mission was done in like 20 minutes. But this one had to go 385,000 kilometers away, all the way to the moon. So we needed bigger engines. And the company that came forward at that time was Rocketdyne. So this is the F1 engine that is attached to the bottom of Saturn V rocket. But that's not just one. 5 engines. Each one produces 1.5 million pounds of thrust. So if you do the math, it's 7.5 million pounds of thrust just for one stage. But the problem came up when we had the first test of the F1 engine. What happened during the first test? If you can notice this engine, you have a lot of rings around it, and you have different sections and segments. Each one has its own test. But the entire thing together, when the test was made, there was a catastrophe, and the first test of the F1 engine failed because the engine exploded. In just 3 seconds, the engine exploded. Nobody knew why. It takes time for any test to bring out results and find out what happened exactly in that mission. So the test concluded saying that these injection plates could not handle some pressure. But nobody knew why couldn't handle pressure. So when a problem happens, what we do is we go to the roots of the engineering. When you go down to the roots, that's where you change things. And that's why I call it elementary change, because it could be a small thing, but we don't know what it is unless we find out during the test. So in this test, as you can notice, these are the injection holes from the injection plate. Each hole pushes fuel and oxygen. The F1 engine requires at least a swimming pool of fuel to burn in just 2 minutes. And this has to be pushed into the combustion chamber at a very, very high rate. So each one of these holes is responsible to push the fuel inside. But the problem is that these holes are not suitable for this mission because the previous ones, the smaller rockets, they were okay. But this one is bigger, way bigger than the previous one. So what did we do? We had to take inspiration from the previous models. But would it work for the new model? Not much. But what do? We modify and we apply that mechanism into the new one. The inspiration was from the V2 rocket. The V2 rockets had a different kind of combustion and different kind of injection. They used nozzles at different spots, and that nozzle pushed the fuel into the combustion chamber. But in the F1, what happened is that the combustion chamber, let's imagine this is the combustion chamber. The rate of fuel burning here was different than here. So the pressure here is different, the pressure here is different. Also the temperature, because the amount of oxygen in this area is different to compare to the amount of oxygen in this area. So this one is burning quickly, this one is burning softly. So if you see that, for the naked eyes, it might look like a small variation. It could go with. But this was happening 2,000 times per second, and that's enough for the engine to rip apart. That's why the combustion instability happened, because of the variation in pressure. Solution? Easy. All you had to do is apply the version of the V2 rocket to make segments on pushing the fuel and the oxygen in different segments in different rates. But they all have to come at the combustion chamber and burn at the same time. If you notice, this design is called a baffle. A baffle is a segment that has different lines in it, and it pushes fuel at different rates, but it all comes down to the combustion chamber and burns uniformly. This reminds me of something that we all know. I call it the Achapam design. It makes sense because Achapam is the same thing, same structure, and now looking at the picture, I'm hungry, I'm craving some Achapam right now. So you can see the design is the same thing. In the middle, you have an opening, and you have segments that push uniformly, and these segments, they will dampen the pressure inside the combustion chamber. Makes it easy for the burn. And after a lot of tests, the mission was successful. But then, once you change something on the elementary level, things might pile up, and you might have a domino effect. The domino effect is some small problem. Back to back, you have many problems, and eventually ending up as a catastrophe. So if you have many issues back to back, you have to solve it by solving each section. So the engineers added an explosive inside the injection plate just to see what if the rocket goes up. After a few moments, it starts vibrating so much because it's a huge combustion chamber. What if the vibration causes instability? So they added this small explosive, but thanks to the Achapam design, the explosive didn't happen. Even after the explosion, it did not disrupt the stability of the combustion. So it worked. That was a successful design, and eventually we had Apollo 11, July 20th, 1969. It went to the Apollo 17 mission. So you can imagine how a small change in the beginning led us all the way to become the species that landed on the moon. Another problem, the cooling system. So the engines have different temperatures, different times. At the max burn stage, you have a temperature up to 3,000 degrees Celsius. That's almost half the temperature of the sun is like almost 3,000 degrees. That's huge amount of Celsius. So how can you control that kind of temperature? Exploit what you have so that you can solve a problem that is causing the issue. So the fuel that you use is liquid oxygen, liquid hydrogen. Temperatures minus 185 degrees, minus 253 degrees respectively. So if you can exploit this resource that you have, you can run it across the same combustion chamber. That will reduce the temperature. So this design of regenerative cooling is using the liquid that you have. Before going into the combustion chamber, make it go around the engine a few times. By this cycle of motion, the temperature of the entire engine comes down. And that was a change done back in the day, and even today, Starship of SpaceX uses the same idea. This was an elementary change that caused a lot of money because we had to introduce a new system of cooling. But if you have the system, just use your own fuel that you have. It's cold, so it's going to bring down the temperature. Easy. So, if you have a plan to change something, the first thing that you have to introduce yourself is to accept that you have to change something. I'll give an example. The willingness to change something came from this interview. I watched this interview, it was on YouTube. A YouTuber named Everyday Astronaut, he got a chance to go around the space camp of Starbase with Elon Musk. While having a discussion with Elon Musk, casually, they were talking about the venting of the gas from the main ullage of the Starship, the boosters. And this guy, he casually asked Elon Musk, you're talking about the venting system. And then he asked him, you're talking about just the boosters, right? Just that one question. Elon Musk took a second, he thought about something, and then he said, wait a minute. If we can do that for the boosters, we need to do it for the Starship, the whole thing. Imagine Elon Musk, the founder of the company, heard a YouTuber say an idea. He acknowledged it on TV, and he accepted the change, and then he applied it 7 months later. And it worked. The same guy went back to the Starbase, and he asked Elon Musk about the same upgrade. He said, yes, we did it, and it was one of the best things that we've done. It saved us a lot of money. We didn't have to make another system for venting, and we eventually had the same venting system of the boosters applied to the Starship. That is huge. So this takeaway is very important. If you want to change something, you need to accept the fact that a change is coming. You need to be willing to welcome it. Once you're willing to welcome it, then you can learn, analyze it. That's the main idea. But it's very important. This one is going to be the one that's going to get us to Mars, hopefully, someday. That is Starship. So the word change could cause anxiety in some people. Because changing is hectic. Let's not sugarcoat it. It's hectic. But the result of change, what is it? Maybe it might work out, it might not. But the process of change is very, very crucial for our development. For example, I'll give you the fact that I talked about the combustion engine. Regulating the fuel that went into it to control the instability. Think about our minds. What is the fuel of our minds? Thoughts. If we regulate our thoughts, we can bring back the stability to our minds. That is one. Second one, the cooling system. You envelop yourself with positivity, you get to cool yourself down. You get to control your substance, which means you can deal with situations more calmly. And that is something that could cause better system for yourself, just like the engines. It's the same idea, same results. So, the last point I would like to say is the one that I said earlier. If you see that there's a need for you to bring out a change, all you do is 4 steps. Number 1, you welcome the idea. Number 2, you make it a necessity. Number 3, you study it. And number 4, you imply it. As we all know, change is not an event. It's a whole process. Thank you.